How you doing? Luther is
Okay.
Luther is my friend from Arizona. He's he's he he's a rancher. He's a rancher dude.
I am. I'm a rancherito.
What?
I think that's what we call ourselves.
So is that what you call? Okay,
No. But
kind of a
it's
weird
it's a
thing
good
to
joke.
call
Yeah,
yourself.
but for the record, I see there's a hi from Scottsdale and a hi from Phoenix, and I think those two guys. I think we all need to go get a beer after this because it is Friday. So just saying.
What's up, Mikhail from Phoenix? I know, there's a lot of Arizona people. Last week, there was someone on TGIK from I don't know where, somewhere near Scottsdale, and then I was wearing my ASU hat. I got it somewhere around here. I don't know where it is.
Well, at least it wasn't your stupid U of A hat.
I got it when I was hanging out with you.
Exactly.
So if you ever are interested in Windows, me and Luther are both big on the Kubernetes on Windows stuff, and he runs the Kubernetes on Windows. He's a TL over at Rancher, and then So I'm glad you're here, and y'all have been doing some stuff with Cluster API and Fleet and stuff. So Luther said he could show us some stuff. So Luther, if you need to queue something up,
do a demo. Oh, geez.
No, you don't have to do a demo. We could just talk about stuff.
Let's do it.
I mean, we're going to start out like we always do with TGIK with the week in review. So for folks that are new to TGIK, hi, Juka Maz from Sudan. I don't think we've ever gotten. Oh yeah, Maz, we've had you from Sudan. So let me go through these. Let me give look at all these. Everybody's showing up here. This is great. KRK4 again. There he is. He's my favorite. Okay. Now I don't have favorites.
How come I can't leave comments?
I like everybody. What you want to comment on your own podcast? What?
Yeah, I do.
On your own TV show?
We did a crowdcast for a masterclass this week, and that crowdcast rig has the whole thing with polls and everything. It was a lot of fun.
I don't know how to do all that. I'm not. This isn't what I'm paid for. So okay. So news this week. Not a lot of news. If anybody wants to tell me about something that I've missed, hey, what's up, Magnus from Australia? If anybody wants to tell me about something I've missed, please let me know, because I'm not too good on at the news part, right? So, who's really good at news is Joe. Joe Beta's really good at the news. He's always got the latest. I'm always like just trying to dig stuff up Friday morning, and I don't ever do that good of a job. But here's something I was looking at. So I usually here's some stuff that I've been looking at. This is recent. Always update the pod IP in case of host networking. So this fixes an issue. When pods are running in host networking mode, they use the Kubernetes node IP addresses. So you can, I was looking into this the other day, you can change the IP address of a node. Now, every time I've ever done this, I've deleted the node from the kubelet, right? I'm from the API server. A meme. Did you all know a meme is on my team now at VMware? We work together. So he says he's going to do a show in a couple of weeks too. So when you have a pod and you change, and the IP address of it changes, right? Let's just jump into a cluster. Like if I was to go, this isn't a good example. I was testing hack local up actually a second ago because I wanted to get as many in as I could. But let me, if I go in here and I SSH into a node, right? I've got a cluster here. So I've got kubectl get nodes. Wide. Okay, just to give something concrete here what we can look at. So my nodes have these IP addresses, right? So if I go in here and I say kubectl edit node here, right? I think this is the status, or is it spec? I forget. Yeah, so this is a status field. The address is a status field, right? So it's looked up, and I think it's looked up. I don't know, Luther, you might know better than me. Is it looked up by the kubelet on startup time? So the kubelet.
Pretty sure you can set it too. There's a param you can set.
I mean, if I set this,
no, when you boot the kubelet,
I mean, you can't set a status field, so
no,
when you boot the
kubelet, never
kubelet,
you can, but you should never set status fields.
Yeah. So yeah, I think the kubelet figures this out somehow, and I think I can read it.
I think my understanding is if you boot it without passing in the param, it'll loop over your interfaces, grab the first one, I think, and then take that IP address and pop it on there and say you're now this. But then you can also force it. You can override it. That's a param. So. And
it's smart at guessing, but I think in Windows it doesn't do as good of a job as guessing in Linux. I remember there's an issue.
Windows an issue?
There's some issue in Linux where it's capable of actually really knowing what your real IP address is supposed to be, like what your external facing IP, even if you got 100.
What if you have two interfaces? What if you have isn't all that vagrant stuff was screwing you up? Isn't that part of it? Was the
Well, yeah. I mean, but I've never seen this a problem in Linux. It seems to always do a good job in Linux, and I don't know how. But maybe it just picks the first one. But anyways. So it's a status field. Well, the point is that it's a status field. And then, so this issue is an interesting one where you've got pods and the pods are running in host network mode, right? But then your kubelet IP address changes. And so to fix it, you work around you actually can restart the kubelet. And I guess somehow, well, it makes sense. You restart the kubelet, the IP address is then fixed, and then when those new pods start up on that new kubelet, they've got the right IP address. And it looks like this is an interesting fix that just came out. That looks like it's. Let's see, where's the PR? Where did it go? Where did it go, Luther? What did I do? Here it is. Okay, so this didn't merge. So the issue closed, but but it didn't merge.
I'm sorry. Was there that much conversation about 2 lines of code?
Yeah, it's interesting. That's why I thought it'd be interesting to look at. So we never fully specified. So this is supposed to fix this. And what he's doing is it's
not even 2 lines of code. It's like,
yeah,
6 characters.
And well, he does a little check in here, right? So this is in the generate API pod status method of the kubelet. So let's go kubeletpods.go. I don't know. Have you ever dug around in the kubelet code? I haven't really. So generate.
I've only as much as I needed to do
this. Well, here we go. You better figure it out quick. Let's see. Hey, what's up, Sevi? How are you doing? I remember this is great. We've got some regulars. We got Sevi and we've got Yusuf. Sevi, where are you coming from today? Yusuf. Where are you all from? Pod. Okay. So the PR is generate pod status, generate API pod status. So creates a final API pod status for a pod given internal pod status. So, so I guess this is the status. It looks the internal, and then it reflects that back onto the API, and maybe just does a status update onto the API server. And I guess what he wanted to add here is a check, which was, now I lost it. Where was it? Where was the PR here? Maybe I need to put this in another. I feel like I need to put you over here. I need to move you over to this side. Okay. So cool. Let's put this over here now. So here's the PR. Now let's go to the file and look at the broader context for this function. So evidently this fixes this problem of pods having the wrong IP after the, so is host network. So yeah, I guess it used to not do this. And what he's saying is that if you just add this one statement here, then, all
right. So when a box reboots and gets a new IP, it's checking to say if something that has host networking and it doesn't, if they don't equal up, then we want to go ahead and reset it to the new one. Yeah. That makes
How
sense.
but doesn't that have to? I guess my question here would be: does this require anything to happen at the pod level, or is this just the only issue is that it's a view? I mean, how do you know that the pod is actually running in the host network?
Isn't that what that thing is?
I mean, I guess it is. It has to be.
The kube container is a networking pod is a bool, right? So it's asking if this pod has host networking, and if the host IP and the pod IP do not match, then it updates the status. That's all it's saying, right? But it used to be if its pod update is not equal to blank. Now it's just if it's any other string, doesn't matter what. Like, let's just go ahead and update it. So I guess in theory this does what he's saying it does, right?
It says it does, but it looks like there's some people saying the similar, like, so it's okay. So pod IPs are mutable. Okay, assume pod X is assigned. What's up, Carlos? Istanbul. Okay, Bonn. Philip Jugelmeyer. Where's Bonn?
Germany.
Is it Bonn? Is that where Friedrich is from too?
No, Friedrich's from. He's a citizen of the world.
Can we see where this? Oh, this looks like Germany. You're right. Okay. All right. So assume pod X. Yeah. So assume pod X is assigned to node N. Pod X starts on node N. So this is Cal. We need to get Cal on here one of these days. Cal wrote the service. What was it? The IPv6 services stuff he did all that stuff for SIG Network, all the dual stack services stuff. I think it was dual stack or IPv6 or both. I don't know. But he's a smart dude, over at Microsoft. The entire representation of pod X on node N changed, but the pod object didn't change. Hence the mutability. Same scenario if the pod was forcibly deleted on the node via container D. So they're saying we can merge it, right? And then Clayton says, we never fully specified the behavior of CNI plugins, whether they had to guarantee the pod IP remains the same when various bits of state were lost. So there is something weird with the state going on here that would be an interesting thing to look at. I don't know how this would all shake out. I feel like something might break if you, I don't know. I don't know.
It's the
yeah,
same.
Go ahead.
It's the same code. It's just that they're also allowing it to not be if the pod IP, because it's saying the code before was if it is a host networking and it is equal blank, right?
Yeah.
So it still works for that case, doesn't it? I don't know. I feel like this is an improvement, but
it's setting it. Yeah. I mean, so I suppose it would be worth testing, and I agree with you. It probably would just work. Yeah. Yeah. You're right.
Better question is, does it pass CI? If it does, just LGTM. Let's move on.
Now the next one. So yeah. So anyways, if anybody wants to create some chaos, change the IP address of a kubelet while it's running and see what happens and see what breaks.
Or change the IP address of the node.
Yeah, change the IP address of the underlying node and then see what happens without restarting your kubelet. I have no idea I assume things in kube proxy would break. I don't know. I don't know what else would break. And I'm not sure how it all gets reconciled. So that's a good PR to read through and study. Better yet, I think the more interesting thing would be do that experiment and see what you can find. Nigel Polton, why you can't ping it? By the way, to that end, we're building reboot tests into the SIG Windows test suite because we found that, for example, one of the things that we've seen is when you reboot a node, you can get OVS rules can get messed with if you're using entry as your CNI. So we're, and we've seen other kinds of issues on other CNIs with rebooting.
Why does rebooting a node mess up OVS rules? That's a whole nother can of worms, or is it simple answer?
Whole nother can of worms. I don't fully remember it, but it's a bug that's fixed. But
it's an OVS bug.
It's not an OVS bug. It's something in the way that things are reconciled at the CNI level. But I think there's reboot. The only reboot tests in upstream actually, like, are for GKE. So there's reboot tests, Kubernetes E2E. But I think the only ones that we have are, yeah, this one, and this one runs for GCP. So these are really cool tests, but you can only run them on Google Cloud. You can't run them anywhere else. So we're trying to make these more generic so that other people can run them on different clouds. So this is a good one. Has anybody here? Minishift. We're gonna try Minishift. Maybe it'll. Well, so here's the thing. I actually kind of played with it a little, and I was running into some stuff. I don't know. We'll see though. I ran into something with Sive, XYHVE, Carlos. Minishift is a miniature version of OpenShift that's like a single node. So if y'all haven't tried it before, I'll show you how to try it, how to run it and stuff. It's cool because you can just play with the OpenShift APIs with nothing else other than your laptop. So this is a good one for folks. Has anybody ever tried to ping a service and it doesn't work? So you can't ping a service, and the reason you can't ping a service is because in general the kube proxy writes rules for TCP and for UDP. And so this article does a good job of it. I think they explain that in this article. Yeah. Because if you look at the IP tables rules, right? I have a thing where I save them. I have like a file where I save all the IP tables rules somewhere. It's in here. And I use this for examples a lot. Me and Sadef created this file together. So if you look in here, right, you'll see like the matcher, right, for a kube proxy when it writes these rules, right? It's like matching to UDP or TCP. But ICMP, when you ping, is like, that's like it's a different layer, right? It's a different protocol. It's like, it's not TCP, it's not UDP, so you can't ping it, right? So
it doesn't work pod to pod too, right?
Well, you can ping from pods. You can ping across pods, right? Like if I'm on a pod and you're on a pod, I can ping you, right? Yeah. So ICMP is a different protocol. It's not TCP. It's not UDP. It doesn't use ports, right? So it's just a totally different thing. So don't ever try to ping a service. It's not going to work, right? We saw a customer do that this week, and I was like, does that work? How could that work? I wasn't sure. And then I had to look it up. Me and Perry looked it up, and we're like, yeah, it definitely doesn't work. Okay. Let's see. Let me get back here and see who else is here. Maybe. Yeah, it's Minishift. It's like a trial version. Yeah. So this is something I'm excited about. Lars, how many of you all saw our episode on kpng, next generation kube proxy? It's the kube proxy working group. We meet every Friday, and we meet at 10 o'clock. SIG network community. We meet, and you all should come because we're making kube proxy better. Luther should come because this, I think, is how you would want to run it on the edge or something. It's faster and simpler. I don't know.
What's the high level to fix kube proxy? What do they actually?
Well, it separates out the thing that talks to the API server from the backends. So it's just so you can make a kube proxy that's really specific to your use case that solves a specific problem that you need to solve. Right now, kube proxy is like a little mono repo, which has all the code for everything all jammed together, right? So what it allows you to do is you have one thing that talks to the API server, and that sounds events down the other way, right? Carlos, Minishift for the old OpenShift, and now. Oh, really, Carlos? Okay. So, do you think we should try OpenShift 4x CodeReadyContainers? I'm down to try that. If you want to put a link in here, Carlos, we can try that instead of Minishift. Because what I found was running Minishift anyways didn't really seem to work very well when I tried to do a quick experiment before we started. But anyways, yeah, so Lars, so yeah, please, Carlos, yeah, help me out there if you can. Yeah, so anyways, Lars just put this out, which is a pull request with an example of how to build your own kube proxy, kpng backend. And it's real simple. You can do it in 50 lines of code, right? And you can, in other words, Luther, like, you know how right now there's IPVS, IP tables, Windows, there's those 4 different ones. So each one of those, if you look at them, they're hundreds and hundreds and hundreds and thousands of lines of code, because if you actually go into the code, there's tons of it there if you look in tree. So with kpng, each thing is a backend and it's totally separate, and it's not in any way coupled to the API server. So each new kube proxy that you add in kpng is just like, 50, 100, 200 lines of code. It's not a big deal, right? So so we'd love to see you all over on Fridays at 11:30. We meet every Friday. It's a lot of fun, and we generally do them as like pair programming. So we don't stare at Google Docs, we don't do proposals, we just hack the whole meeting. So it's the only SIG network that I know that's like SIG meeting that I know that's like that. So it's a lot of fun. And there's one other thing that I thought was interesting that I ran into today, and I didn't know how to solve it, so I asked a Stack Overflow question about it. Yeah, this one, go mod. So I asked this question, and I would love to see if anybody could answer it here. So when you do a go mod, when you pull something in, we have this problem, and it's actually related to what I was just talking about, which is that I noticed that when you have a go module and when you're importing something, you actually, like, your package, like if you're importing something from a specific package and you do go mod tidy, then go mod tidy has to pull in everything from the repo that you're importing that one package from, which is kind of annoying because the one package you're importing may not have a whole lot of dependencies. So I was wondering if anybody in the world can tell me an easy way that I can import just one directory of code from a large Go dependency in go mod. And I don't know a good way to do that, and I haven't been able to find a good way to do that. I asked a few people and couldn't really figure anything out. So I'd be real interested in if anybody has any ideas about this question. So yeah, tgik.io/notes if anybody wants to jump in. Thanks. Looks like Kubefire bootstraps it. Does Minishift Moz? Does Minishift require too much resources to run it locally? I don't think so, Moz. I think you can run it in like 2 gigs of RAM or something like that and 2 cores. I mean, maybe we'll find out if we can run it. Try Kubefire. Kubefire bootstraps your K8s cluster on top of Firecracker via Weave. Okay, so Firecracker. So that means I need does that mean I need Amazon to do that? I don't know if I have my Amazon account working right now. If you have a fast connection and lots of memory, like 9 gigs free, then you can use what? Use what, Carlos? Minishift or CRC? Yeah, I've got 9 gigs on this box. I've got I'm not like Luther where I have a data center in my house, but I've got 32 gigs of RAM on this, and I've got 8 cores. So, I mean, it's enough for me. So, okay. CodeReadyContainers. So maybe we'll try this instead. Thanks a lot, Carlos, for helping me out with this. Okay. So let's go over to, so I wanted to start, let's see how far. Okay. So we're 30 minutes in and we haven't even looked at anything yet. So here I am, like, wasting everybody's time with weird corner cases in the kubelet. Where were we here? Right. So, where's my Azure console?
What you gonna boot?
I think I've got, there's Minishift. There's that. There's Google Cloud. Here's Azure. Cool. So I started an Azure thing up just so we could do this cooking show style, because I wanted to just get started and start looking at stuff. So I haven't really done much with Azure before. So kubectl get pods. Well, I haven't done AKS. I've done stuff with Tanzu on Azure, which we'll also look at, but I haven't done much with AKS. So, all right. So I was able to get this to work. So let's see. So this is an Azure cluster, and I'll show you how to make one in a second. They're not hard. We could just use the thingy. We don't have to do it through the terminal if we don't want. We could use the AKS terminal also, but I like to look at the options here. So so if I go back here, Yeah, there we go. So if I go and I want to run AKS, right, here I go. I could just do create a Kubernetes cluster, right? And so you have to have an Azure subscription. This is like a fundamental thing. It's like the thing that you get when you create an account. And it just, you have a hard link to it. So I can make this like Luther. Hi, Luther.
That's the best
Hi,
possible
Luther.
in a long
You
time.
like this? Yeah.
It's not my
It
favorite,
won't
but
let me do it. It won't let me do it. Hold on. Okay, there we go. So I can make this a US East 1 version here. Okay, and I can turn on auto scaling. Then I did next pool. I'm not going to create this because I've got one over here. And virtual nodes. So what's a virtual node? Enabling virtual nodes allows you to burst containers on nodes backed by serverless Azure. I guess this is a cheaper way to scale, like have ephemeral infrastructure on the side for cheaper. Is that the idea? And so for Windows, you can create a node pool, right? So I could say Windows 22. Okay, I can't. It has to be less than, so I have to call this like Win2, right? And then you pick your AZ for the thing, for the node, and then you can add that. So you add Windows by doing a node pool.
does it not force you to have the Linux node too, though? Is that first node pool that was already there was a Linux worker node?
Yeah, I think it forces you to definitely have, obviously, to have a real operating system. To have a real one. Yeah. So there you go. So that's how you would create a multi-OS cluster. And so Azure RBAC, have you ever done anything with this?
No.
So I think I don't understand what this was confusing to me. I started playing with this morning just to see. So there's an Azure RBAC option, and
are they adding RBAC rules for your Azure accounts so that other people can log in that are within the Azure?
Yeah, I think that's the idea, is that you can use your Azure account, enable Kubernetes role-based access control, which provides finer-grained control over. So I'm assuming that, yeah, it's somehow.
So everybody else inside your Azure account could get into this cluster based on their authentication.
Based on their credentials, yeah. So, and then you can also, I guess, integrate Active Directory once you enable that, maybe. Like if you disable it, you can't integrate Active Directory, right? Mm-hmm. So I'm assuming that that's the whole idea, right? Is that you would enable this, and then the canonical thing you would do with it is you would then enable Active Directory, and then now that you've enabled Active Directory, maybe there's some other thing you do here, right?
Yep.
So so then you do that, and then you review it, and you create it, and then you fix your. I didn't do the right thing on the networking. We're supposed to be good at networking here, so I don't know how I screwed that up, but okay. What did I do? Yeah. So the networking options are, wow, that's weird. Okay, let's just start over. Here we go. Create. All right, so if we go to networking, we're not going to make this anyways, so it doesn't matter. But yeah, so you can pick Kubenet or Azure CNI, and if you do Azure CNI, you kind of have to create a network first. So create a new network, subscription resource. So they want us to actually set all this stuff first, right? So we can just use this one. We'll do Luther again. And node pools. We'll forget Linux this time because I just only wanted to show it to you. And then we'll do networking. And then here now we're using, we could just use this virtual net. That's fine. And so we could do Kubenet, or we could do Azure CNI. And how do we enable network policy? So we can actually, so I didn't know this. This is news to me. I guess you can enable network policy through Azure. So there's such a thing as Azure network policy. I didn't know that. This is evidently a Azure native implementation of the network policy API. So we could see in here, let's see if they create namespace, backend, run, kubectl, and then there they are. They're creating a network policy. So I guess there's multiple options for implementing network policy. One is Calico. So if you do this, then you don't have network policy.
All right, you got to acknowledge Choco down here with no cillium ? Frowny.
Yeah. Hi, Alex. Did you just get here? Yeah, you missed a couple of things. So Alex, Luther's here from Rancher. So we're excited to have Luther. And then
Luther was told he's only going to be here for 5 minutes, and Luther has to go in 25 minutes. So
well, how much time? Well, you got to go right now?
No, I have to be somewhere at 2:15.
You got to go at 2:15. Okay.
Oh no, I got to be there at 2:15. So
all right. Let me get through this, and then I'll give you.
I'm not pushing you. You're good.
You're totally.
Wait, hold on. Let's acknowledge no cillium. I mean, cillium doesn't work on Windows. Why would Azure put that on the back end of anything?
So they don't have a Cillium Windows solution yet. So Cillium, we want a Windows offering. So if you want production grade CI on Windows for Kubernetes, you've got to go with either Andrea or Calico. You can do Flannel, but you won't get network policies with Flannel. What do you support over at SUSE?
So all the RK2 stuff is Calico now, and all the RK1 stuff for Windows at least was all Flannel. Okay,
cool. So if I look in here, and then after this, I want to show you some Tanzu stuff, and then we could do some Rancher stuff. So if you look in here, and I do get pods.a, the first kind of thing that I think is interesting is you don't see the Calico pods running here, right? So in a normal cluster that was running Calico, you would see the Calico daemon set running, and then you'd see the Calico controllers running, right? In this case, you don't see that. You just see the Tejera operator. So I was kind of wondering about this, and I guess when you create an Azure cluster, Tejera operator Azure, there's a native thing here. So Tejera announced a preview of Calico for Windows on Azure Kubernetes, while Calico has been available for self-managed, blah, 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 blah. So enterprises. So I guess when you pay for Calico on Azure, Tejera operator somehow does it magically. I don't know what they do, but under the hood, somehow they implement the functionality for.
Do you think they're running something on the nodes?
I have no idea, what they're doing.
Do you get access to get in those nodes? After they boot up, can you SSH into them and check them out?
Can I? How would I do that?
I don't know. Is it in the UI? Do they have IPs? Do they have places? Do you have?
Let's see. I want to try this. Let's see. So can I do?
I bet they keep you out of it.
How do I? They can't. Here we go. They give you a bunch of stuff. So after you create a cluster, then they give you this, and then you can open Azure Shell, and then you could get in there. But so maybe I can go and I can look at the nodes, right? So maybe I can go to here. Resource group, it would be in here, right? So if I go to my resource group, then I can go to nodes. No, I mean machines, virtual machines. I don't know. I think there's an all resources, right? So there's all resources, right? So if I go to all resources, this is what gets created when I make an AKS cluster. So then I've got a virtual machine scale set. I wonder if that's the thing.
I mean,
it doesn't look, yeah, I mean, it's got an IP address. So maybe if I've got an IP address, maybe there's a way I can get in here, right? So if let me know, folks, if the screen's font is too big or too small. I'm always making it too small, and everybody yells at me. So I tried to make it really big this time, and now I can't see anything because it's too big for me because I'm so close to it. All right, so I mean, I could restart it. I could move it.
Just be interesting. I didn't think on EKS you could get access to some of those things.
I don't see how I would. I see that there's I see the capabilities. I don't think they want me to get in here. If I am able to get in here,
working on that.
Siri, Siri, I'm not talking to you. So I don't know. More. There's more. I don't know. So if anybody knows whether you can get into an SSH into AKS node, can you do it? Evidently, it says you can. Oh, you can run a container. What?
That's
cool.
Access. That is cool. Do that.
Okay. Okay, let's see. Can we do this? All right, let's do this. All right, so I can... Where did my thing go? Where did my little console go? Let's go back to the console. Okay, here we go. So I was in here, and then I opened a terminal. Connect, right? So then I can connect in here. I can open a Cloud Shell. I love this Cloud Shell thing, by the way. I love the whole Cloud Shell thing. So evidently I could do something like this, and then you can StreamYard, get out of here. Yeah, ICMP is on top of IP. So it's on top. So ICMP runs on top of the IP protocol. Okay, but it's not a yeah. So that makes sense. Why? Okay, so debug the node. So I got to get the node name. So that's this. Okay. So let's see if I can do this. So if I debug the node, if I join this debug container, what happens? I didn't even know there was a kubectl debug. What is that? Create. Is this a thing?
I've never used it.
I didn't know this even existed. Oh my
Debug, right?
Whoa, it's a thing.
Well,
it's not a,
no. That's just logging.
No, it's not a,
there it is.
No, it is. If you can instead add a debugging using kubectl contain, so it's a thing.
Huh.
So that's interesting. So they must be a kep on this then, right? So if I do kubectl debug, somebody probably wrote a kep on this, right? So then we could go read that kep. SigCLI, kubectl debug. Did you all know about this? I bet you all learned something. Everybody learned something new today here. What's up, Alex? Did you know about this? You came late, but you came in like at the perfect timing because we got to learn something new. This proposal adds command to kubectl to improve user experience with troubleshooting. Exec and port forward allow troubleshooting at the network level. Extend these to include Kubernetes abstractions such as pod node and ephemeral containers. Create an ephemeral container running in a pod. So it probably just launches some kind of, yeah. So if I made another connection, I'd probably, so okay, I'm in. And so now I can do ps-aex and I could see nothing on the node. What are they doing?
Do an AUX and then
there's nothing. Like if I go in here and I read every process on this node, the whole purpose of why we were doing this was because we wanted to see what Calico was doing on this Azure cluster, because we don't see Calico node containers and we don't see, yeah. So anyways, I think that's,
right?
Yeah, I want to move on. Moz, kubectl debug, it was 119. Okay. Thank you, Moz. OC debug. Ah, okay. So we stole it from OpenShift, huh?
Well, you haven't taught Moz anything new today, so you got to keep going.
All right, Moz. Moz knows what's going on right now. All right, so let's go to let's go back here. So what did we learn today? Today we learned, so, you can kubectl debug a node. Okay, cool. And then, so for that, still didn't see any Calico infrastructure. So here's what I think is happening. I think it must be integrated somehow into Azure CNI, and then what's happening is there's something that's running Tejera operator. Every time you make a new network policy, Tejera operator is probably directly creating firewall rules in Azure CNI. That must be the thing that's happening somehow.
Could
right?
the Tigera operator be talking to the Azure API and just doing the bits and pieces behind the scenes, and they're doing it all hardware?
That must be what it's doing, right? Like, because if we were, So
I mean,
if we have
better question
time,
is that Tigera operator, is that version of it open source, and can we go check?
yeah, it is there, and it is there. I'm not against checking on it, but I want to jump to the next thing. So because I want you to get a chance to show us the Rancher stuff, and we're already 45 minutes in. All right, so okay, so let's go here and let's jump. I have another machine over here where I've got some other stuff running. Let me turn on my screen share on this machine.
By the way, you make fun of my data center in my closet over here, and you have like this command center thing going on.
Yeah. I've just got a bunch of computers because that's because I don't have one good computer, so I use like 10 different ones. Okay, so let me share my screen. Okay. Yeah, here we go. Yeah. Here we go. All right, so, all right, good. Let me share my screen. So let me see if I can let myself in here. How do I let myself into my own? I'm going to add myself into my own. There we go. Okay, we got some inception going on, but that'll go away. All right, cool. So I'm going to do, so I'm going to show you how we create, I'm going to show you, so now I'm going to show you some stuff with VMware Tanzu. So we just did some stuff with Azure. So with VMware Tanzu, we use a thing called Cluster API. So the idea behind Cluster API is that you have, just like in the Azure cluster, we had, we had our Azure console, right? And when we were in our Azure console, we were, doing, Azure commands and clicking on stuff to build stuff. So with VMware Tanzu, right? I could do Tanzu cluster list, and of course Azure also has a command line as well that we didn't really use it, but like. The VMware Tanzu is much more driven from the command from the perspective of like sort of like a build your own multi-cloud sort of experience. So in this case, we have I'm showing you Vsphere, but we also support Azure and we support EC2 and all sorts of stuff. So we support other experiences, and we've got a native thing called TKGS that's built into it. But so you could see here, I could do Tanzu cluster list, but I could also kubectl. Let's do kubectl. So if I do kubectx, you'll see that there's two different clusters here, right? So I could do kubectx, and I could move over to my management cluster. So my management cluster is right here, and you could see on my management cluster, I've got like 4 different nodes here. I've got a management control plane node, and I've got 2 workers, right? And so I could do kubectl get nodes, and when I run kubectl get nodes, you could see I've got these 2 nodes here. Now I could do so I just made a cluster, right? So I could do Tanzu cluster list, but I could also do kubectl get clusters. Okay, because cluster API it's an upstream Kubernetes like management API where you use Kubernetes to manage Kubernetes itself through CRDs. So I've got all the native I can manage all this stuff using the Kubernetes, all the regular native Kubernetes tools, just as if it was any other CRD, right? So if I do kubectl get CRD, you'll see that in Tanzu, we have all these different CRDs for everything, right? So
did you guys end up doubling up the CRDs? Do you have cluster CRDs in Tanzu that you then have copies of essentially and from Cappy?
So yeah, we use it's very close to the upstream, right? Like, so we add stuff on top.
Yeah.
Right. But like
what we did too
for Tanzu, but like we don't like, the cluster API stuff is the cluster API stuff. And then we
can see them all right there. You got the K8s IO, the X8s.
Yeah.
Yeah.
Go ahead.
No, it was just interesting to see you guys did very similar stuff to what Rancher did too.
Yeah, so I'm looking forward to seeing what y'all did. So for us, and the way that we manage clusters is that we do this thing. So we use YTT to define the clusters, right? So like in this case, I'll show you like for example, infrastructure vSphere, right? If I go in here and I do YTT vSphere overlay, YTT. Why am I? Oh God, infrastructure vSphere v07. right? If I go in here, let me tree this. I don't have tree on here. So if I just, let me vim this directory, you could see that there's a directory structure here where I have a developer and a production template. And these are mostly the same, just one has more control plane nodes or whatever. But if I go into these YTT templates and I go in here and I look into these base templates, then this uses YTT, which is an open source language, right? For clusters, YTT. So if I go to YTT Carvel, YTT is just an open source YAML templating tool, right? So you can try it here in the playground, and it's a generic. It has nothing to do with Cluster API or VMware or anything else. It's just a thing that allows you to change. So I could change, for example, this port to this, and then I can run the YTT, and you could see that it substituted my YAML this way. So we use that. We just reuse this tool for how we define and manage clusters in VMware Tanzu, right? So, and so like if I want to do, so anyways, I could do koops. So I could do Tanzu cluster list. I could do Tanzu cluster delete, and I could just list the name here. And as soon as I do that, we could see over here that if I jump in and I look at the CAPI logs, kubectl get pods -a, I could kubectl logs.
Hey, Jay,
Yeah.
I'm getting the stink eye. I gotta go.
Okay. All right. We'll see it.
How long are you doing this for? Can I come back?
I'll be. Yeah. Can you pop back in a little bit? We'll be around for. I think this might be a longer show, so if you could pop back in 20 or 30 minutes, we'll be here.
That might work. Okay. Bye for now.
Yeah. Okay. See ya. So yeah, Luther didn't get to stay for the whole show. That's fine. We can maybe look at the Rancher stuff on our own. So, okay, back over here. If I go kubectl logs and I look at the capv controller manager, so this is a container, and its entire job in life is to -c manager. Its entire job in life is to continuously reconcile the desired state in my cluster that I've asked for, right? So yeah, so we could see here that we deleted this. We're deleting this cluster, and we could see, yeah, we could see success. Well, yeah, so these should be getting turned off. So these machines have been reconciled and turned off. So when we first started, there was more machines there, and then we can do the same thing as we can tail these logs. So we could do, yeah, we could tail those logs, and then we can literally recreate this cluster. So let me just, I think I have this in my history. So if I want to recreate, yeah, if I want to just recreate that exact same cluster, right, I could do that, and I could see over here that I've got a pod that's doing all my infrastructure work. So this is, in my opinion, Cluster API is really nice if you want to know how things are working, and you want to be able to modify things using kind of Kubernetes native tooling and everything else. Cluster API is a great solution. And we have other things like TMC, which allow you to sort of automate this, and we have UIs and stuff on top of this. But I wanted to show the upstream sort of inner workings of all this for TGIK today. But as you can see, these VMs are now coming up in Vsphere, and then these Vsphere VMs will then get glued in via via kubeadm when it starts. And for folks interested, as this comes up, the way this works is it uses a tool called Cloud-init. So I don't know if folks are familiar with Cloud-init, but Cloud-init is like sort of a protocol for bootstrapping a machine with what it needs to do when it comes alive. So if I go in here, I can see that these machines come up, and people use this on Amazon. They use it everywhere, right? It's not a VMware specific thing in any way. Cloud-init can be used anywhere on any cloud, really. And in fact, I think you can use it on some things like VirtualBox and stuff, but I'm not quite sure how. But anyways, if you look in here, then actually this data is embedded into these machines when Cluster API boots them. And so these are actually secrets inside of my cluster. So if I can do kubectl get, if I go in here, I could see, kubectl, we could see there's these kubeadm configurations and kubeadm config templates and kubeadm control planes and all that stuff, right? So if we look in here, there's bootstrap data, and the bootstrap data is managed through all these different CRDs to like get loaded up by these kubeadm configurations. And ultimately a cluster in cluster API is just something that glues together the concept of a machine deployment, kubectl get machine deployment, right? It like this just got created. This machine deployment is a thing that glues together this concept of a machine deployment and the concept of these kubeadm config templates, and then uses a thing called a bootstrap provider to put this secret in here. So that secret that I copied, for example, to show you, like I could just cd to temp, and I could just vim bootstrap data, and I could just copy that entire secret, right? And if I was to copy this whole secret and I just cat that secret that I saw there and like base 64 -- decode it, then what you'll see is you'll see like all this stuff that looks like this looks familiar, right? So what this is doing is it's writing out the CA, right? So this is what cluster APIs bootstrap providers do for you. They generate these secrets, and then they write those secrets out, and then they make a boot command that basically runs kubeadm init boot, and then it uses this file, and that file is also included in here, right? So like so there, that's the way this whole thing sort of like boots, right? So you could see there's and then you could see it's got this other thing in here called we use a tool called kubevip. So kubevip gives you the ability to make a vip in your it gives you make a vip in your inside your data center, right? And so that's like the whole like Tanzu experience, right? That's how I was showing him, Ricardo. Hi. So I was just showing him how Tanzu bootstraps stuff through the cloud init stuff, right? So so it like adds these little secrets inside your VMs, and then where is it? Here we go. If I go to here, and if you go into edit settings, so I'll show you all again, because this is important, because this is stuff you use in almost any cloud. People use this for any kind of automation, right? So exactly. So you could see all this, and you could do the same thing if you were running in Amazon. Chances are, if you're doing a whole bunch of stuff, you're using cloud init data for bootstrapping your VMs in one way or the other. So that's like the VMware Tanzu thing. And then so now I can, if I want to look at the other CRDs that we offer here, right? I can say kubectl get Vsphere cluster, I think. Yeah. And I could also get cluster. A cluster is a generic part of the cluster API. It looks like you dropped. What's up, Ricardo? So a cluster is like a generic concept. And so there's a cluster, and then there's a Vsphere cluster, right? Is the idea. So, and we could draw this out if we had time later. I think I have a diagram of it somewhere that I could show folks. I have some ugly diagrams. I have a notepad diagram I could show people. Ricardo, I can't hear you, man.
Because I was muted.
Yeah. Okay. So, so that's the VMware Tanzu experience. So we just released Tanzu 1.4. We're excited about that. And right before this, we were just looking at Azure. I don't know if you knew about this, Ricardo, but you can in Azure. I'm going to turn off my screen share on this machine now. Stop screen share. There we go. So in Azure, you can. Have you heard of this kubectl debug command, Ricardo? By the way.
Yeah, it was created by Lee Verb, I guess. It's cool. It's a cool thing. You can attaches a debug container.
Yeah.
In a pod, and so you may have like in your runtime you may have in your runtime like distroless, something without anything inside, and you can just attach something to debug that container, that
Yes.
pod actually. So that's really cool.
Yeah, so we were just looking at that. Luther was just here and we were just looking at this. But so one of the questions we had, we're going really fast because I want to show as many cluster types as I can, but in 10 seconds or less, can you tell me why it is that there's a Tagera operator on this AKS cluster, but this AKS cluster isn't running Calico node or kube controllers? I think the Tagera operator just natively programs firewall rules or something. What's up, Martin?
Idea.
He's back. So yeah, that's an interesting thing. I don't, but it was interesting because we created a cluster with Calico and we didn't see it. So, I guess I should actually show how the Entria stuff works since I have a cluster over here in our, so let me actually reshare one other time before we jump over. Here we go. Yeah, so if I'm in here, I could do kubectl get pods -a. And so we could see, when I say I think it's weird that we didn't see anything, like if you look in here,
hold on, Jay.
Yeah.
We need to add your screen again. Which one are you?
Yeah, let me see.
It's not shared.
Oh, I didn't share it. Thank you.
Yeah.
There we go.
Yeah.
So if you look in here, we'll see normally, right? This is normally what we're used to seeing, right? In a cluster, right? You have two CNI agent pods and you have a controller, right? So I have a 2-node cluster here, right? So that's kind of in contrast. So yeah, we could see our Entria agent rules here, and then kubectl logs there -n kube system -c Entria OVS, right? Entria agent. The Entria agent's the thing that actually does all the programming. So normally you would have an agent, right? That's like writing, and normally that's the same thing in Calico, right? You would have an agent, and that agent would be writing all these rules. Now, the other thing, when you make a cluster in, let's see here, grep-r Calico. So we also support Calico and Tanzu, right? So we aren't super opinionated about our ./.config. We're not super opinionated about the CNI. So you can, if you want, for example, you can run TKGS or TKGN with Calico as a CNI. Let's see here. So we allow you to set the network, and again, you could do all this through ITT, right? So, and there's, let's see here. If I do VM config Tanzu, yeah, let's see here. So if I go in here, it's just one parameter. Yeah, data values.cni. So I can just, in my cluster definition, when I create it, so we create our clusters with YAML, right? So we do vim, like in this one, vc entria.yaml. This was an Entria cluster, but like literally I could just change this, right, to Calico, right? So if I did this and I changed it to Calico and I created it, I could just create a Calico cluster. And right now we support Calico 3.13, but we're moving up to 3.19 in a few weeks. So anyways, that's that. When I say few weeks, I mean, we're going to start working on it. So I don't know when we're going to release it. Yeah. So Azure, we've got Tanzu. So let me kick myself out from my, okay, there's my work computer is gone now. And now I'm going to put my play computer back. So Ricardo, what's going on?
First of all, I am really sorry that I am late. I got stuck on traffic. Sorry, folks. Yeah, got like 15 minutes to get home. So what are we gonna play now, Jay? Minishift?
Okay, so Minishift. So there's this thing called CodeReadyContainers. So I don't know what these are, but evidently our friends at Red Hat have got this thing called CodeReadyContainers. So I tried to run earlier, before this started, I tried to run a Minishift, which is what I thought was the way that you created local OpenShift clusters, but then Minishift failed. And I don't know why Minishift failed. I think it's related to this XYHVE. So anyways, I guess I can just try this. I've never done this before, but I guess there's another. No. What? Is there a sandbox I can use? No. Hold on. Come on. Don't tell me I have to give my... Okay, is anybody from Red Hat here? Can you tell me how I can just get this thing working? Let's see here. Is there a GitHub repository? CodeReadyContainers. GitHub. I'm not in the mood to do a bunch of email stuff. What's up, Martin? Yeah, Ricardo left and then he came back. So, okay, let's see if we can just run it directly from source. This project is focused on bringing minimal OpenShift 4x. So huge thanks here to Carlos for telling me about this. Carlos, use the playground instead. CRC requires a free Red Hat account. I think I have a Red Hat account. I don't mind using it if I need to. So I could use the playground. Okay, fine. Let's do the playground. Why can't I use this though? Really, I can't just... I guess, yeah. Interesting. Okay. Cool. Oh, but then they reference Minishift. Okay, yeah. So for 3x, you're supposed to be able to use Minishift, but then when I did this, I ran into this and it couldn't find an IP address. And I couldn't figure out why it couldn't find an IP address, but this looks like a Xive error, which is this like virtualization thing for Mac. So something is happening where Docker is starting up and I don't know, trying to get an IP address. It's trying to use this to create VMs, and that is a thing that ultimately we'll call the VirtualBox API. But then I thought maybe if I didn't use VirtualBox and I just used the native Docker driver, maybe that would work. But that also, oh, actually it's still using the VirtualBox hypervisor. So maybe that's the problem, is there any other drivers I can use? Because I know Minishift has multiple VM driver equals, what are the driver options?
Docker, known. I guess if you put known, oh, there is no known.
What if I do VM?
Yeah.
What if I do HyperKit?
VM or Fusion? Don't you have Fusion? HyperKit, maybe, yeah.
Yeah, I could try Fusion. So let's try HyperKit. Maybe we can get a Minishift VM. Use it playground. Oh, I think Carlos left some notes. I'll read your notes that you left, Carlos. Where did you leave these notes for us? So Carlos is super helpful. He jumped in here and he gave us this. Okay, so we went in here, and then we went in here. Oh gosh, see, Ricardo, this is like that hour mark where my brain starts to get all... Okay, so far nothing is broken yet, so maybe this will work. But so let's go to the link Carlos gave us. So 4 cores, 4 physical cores. How does it know the difference? Okay, on macOS, CodeReadyContainers requires macOS. We've got Maha. Okay, we're fine. Installing. Okay, so it still doesn't work. So actually, no matter what I do, it seems like it doesn't like... And we could just try every driver here. So Minishift. Okay, yeah, I've got VMware Fusion, I think. But you know, it's like it seems to me like it's happening at the level of like before Fusion happens, like XYHVE, whatever that thing is like a thing that talks to the VM under the hood, and then that's breaking. And there's something about our ability to use that thing. So does this use Xive too, Carlos, you think? Let's see. So they're saying I can... Okay, let's try it. So like if I... Okay, let's just try this. So they want me to CD to downloads. So we'll try this at the same time, right? So let's CD to downloads. Okay, so I'm going to go here, and then too small,
so
right?
Carlos asked us to use CRC because OpenShift 3 with Minishift is really, really, really old, outdated,
yeah.
actually.
Okay,
so maybe
no wonder. Okay, cool.
I will take a look into the code ready CRC and see if I can run here in my machine.
Yeah, see if you can get it working. Okay, so meanwhile, if I go and I try to download it, do you have a Red Hat developer account? Are you logged in? I have one. Can I?
I do have.
Let's see if I remember what the password is. Failed. How many times until they lock me out? Oh, gosh. Okay, forgot my password. Send me a password, Red Hat. Send me a password. I'm trying to promote your product. Register for a Red Hat account. Forgot my password. There you go. Okay. Here we go. Let me see here if it's in my email. I'm on my other screen now. No, not yet. Come on, Red Hat. Come on, it says TGIK.
You can use your account from GitHub. Don't you want to link with GitHub?
You can?
Yeah, I am linking with mine. Red Hat wants to use your own. Okay, sounds good.
Watch this. It won't work because I already have an account. Because I'm more Red Hat than you. Like I already have an account. It's easier for you. If you win, then it's because you cheated. Hold on.
I'm in.
What am I? What am
And
I?
I can launch.
TGIK.
I can launch my sandbox here.
You want to show us? You want to just show us? Here, I'll give you your. Okay. All right. Why don't
Sure.
you join? Why
Just
don't you show us?
Let me just separate my screen here.
Okay.
Okay. Let me see. Share screen. Select window. I don't know if I can do this. What's this? Not this one. Okay, maybe this one.
Now everybody knows where I live. I started getting weirded out by this whole thing and moved the thing off the deal. I was like, okay. All right, here we go. Now I'm in.
Okay, so do you want to share your screen or do you want to see mine?
No, I'm going to share yours as soon as you bring it up.
Okay. So let me put my, where is my screen?
Wow, I don't see your screen.
The browser can't access your screen.
Customer cloud subscription. Okay, so now they give me a EULA. Yeah, once yours comes up, I'll add it, and then.
Yeah, it doesn't allow me to share my screen.
You can play with it for a little while. Just play with it. It's no rush. I'm making progress. Okay, good. So I can do this upgradable free trial. So it gives me the ability. This is a lot like, wow, this is just like a real regular. This is interesting. So they want me to put a service account JSON, and then so I can call this Ricardo. So they want me to put a service account JSON in here. So how do I get a service account JSON? I have a Google account here. So is there a way I can just get a service account JSON? I guess I would want to do this offline so y'all can't steal my service account. So GCE get service account JSON. How do I do that? I'm looking for it up here. So, okay. Google IAM. Okay, go to service accounts. Select a project, click the email address, click the key, select JSON. Okay, I've done that before. Okay, cool. So if I go to service accounts, okay, and I select a project. Here we go, that one. And then I go into where is the, yeah, I guess I can just click on here, right? And I'm going to make my little teeny tiny screen so you all can't see my service account. Finally, my, the fact that I never have the screen big enough actually benefits me. So, all right, permissions, keys. So I can go to keys here and I can do add a key, create a new key, and I'll create a JSON key. Okay, and then I can save that. Okay, so cool. So I saved the JSON key. So I have a service account key. All right. Now I go back here, and then evidently I can upload it, right? So I can go here, and then I could go to downloads, and I can go to service list. Where is it? Date added? Just right now, right? It's this thing. Okay. Okay. Cool. I'm going to hide this because I have no idea. Wow. Okay. So I'm going to hide this and then move my monitor back up. Here we go. Okay. Don't steal my Google service account. Here we go. So now I'm going to try to create a cluster. Okay. Oh, service account name is different. So, okay. So, oh, so they want me to like have the same service account name. What is this admin thing? I wish your thing worked. Where is the... In order to create a customer, you must have a service account. Oh, and I have to name it that. So I actually have to go back here and create a new key. Create a new key. How do I rename it? I don't know. I don't know how to rename this key. Details. Name. There we go. Save. I have to do that. I got a new Ricardo. Ricardo came. We got two Ricardos. Which one do I... Okay. But now we don't have your audio. We'll just add you both and we'll see which one works. Okay. Ricardo's having audio issues. That's fine. So I've renamed my service account to this. OpenShift, delete me. Okay. And then I suppose that this just works now. So there's no save that I have to do here. So now what if I try this again? Oh no, I'm sorry. I named it the wrong thing. I need to name it this. Okay. Manage details. Oh, save. That's how I do it. Okay, so now I have this key, and now can I download it? Let me create a new key. Okay, so I'm going to call this that so that I don't screw it up. So now I've downloaded that, and then now this is a new service account, and I'm going to get rid of the old one, and I'm going to browse. And here, see if I can do it. Oh, here's Ricardo. Now we've got Ricardo. There you go. Okay, so I'm removing the old you. Can you hear me?
Yeah, I
Okay,
can hear
cool.
you.
All right, cool. All right, so let me try this, and then I'm going to give the screen over to you if you've got something. So you got another 2 or 3 minutes to see if you can get something more. Wait, I fixed it. Didn't I just fix this? Yeah. Were you able to get it working, Ricardo? It doesn't work for me.
I am downloading the local one.
It doesn't like my service account. Okay. Let me know once yours is working. I think I'm close here.
Okay.
I don't. It's this. It doesn't like this service account, and I don't know why. Nice house. Whose house are you talking about, Alex? Automatic. I don't know if this thing's trying to give me hints or what. All right, so if I go to service accounts, what are the names of them? So if I go to service accounts, Yeah, that's definitely the right service account. So what if I just delete this service account entirely? Oh, I can't. Okay, so I'm going to disable that service account. I'm going to create a new one. And I'm going to call the new one OC. There it is. Okay. Created a new one. I'm going to give it to the only project I have this entire Google account. Can I just give it everything? Owner? Okay. Okay. So now maybe it has to be created. Yeah. That looks a lot better already. So maybe it needs to be, it's not about the name that you set in there. It's about the name that you create, the actual name. How's it going over there, Ricardo?
So I've just downloaded OpenShift CRC, and I was going to install in my machine. Do you want to see? Do you want me to share screen?
I think it might work this time. Yes, try to get it working, and then let's see. I'll try to get mine working, and then we'll see.
It seems that yours is working.
We'll see. Yeah. So is it coming up? Is yours coming up?
I was just about to unzip it.
Go ahead and share your screen, and I'll try to turn it on once.
Sure.
Yeah.
I will just open a new streaming. Just don't put me, because I need Google Chrome to share properly my screen. It's not working on the other browser.
All right, cool. So it looks like this is doing something on my end. Something is happening. It's creating an account. It's creating a Red Hat. So I guess to try out OpenShift, or what's now called, I don't know if, I guess OpenShift 4, in order to try that out, what you do is you register for a Red Hat account, and then you do, it's a much more streamlined sort of cloud sort of native process where it kind of gives you a cloud cluster that you can actually play with. That's like a real thing. So it's setting our account up. Now it's doing the DNS setup. I see another one. So you want me to add this one, Ricardo? Okay.
No, don't add me yet, Jay.
Don't add you
I will
yet.
add my. Yeah, I can. Once you are ready, I can share my screen and show you.
Okay. So now it's installing. Looks like it's installing a cluster now. So while this runs, let's go and let's look at I didn't want to just do products. I also wanted to go through some examples of like, you know, like, well, my favorite is hack local-up-cluster, right? So this is one where I can go in here and I can say, we have kind, and I didn't do kind because everybody knows about kind, and I've gone through it before. We have this thing here. If you go to cd source K, I have this here, and I've showed it to people before if they ever want to try it, where I've got a bunch of kind demos that I use. So if anybody wants to try the recipes that I use on TGI K8, you can go to, here, and then you can just go into kind, and you can just try this kind local up script. And you can just literally clone this repo down, and you could try this script out, and you can start it with Cillium or Calico or Antria, and I've shown that to people before, so I didn't want to show that this time. I wanted to show it something different, which is my favorite way to like hack on Kubernetes is to use this thing called a local up cluster. So if you clone down Kubernetes itself, you ever use this, Ricardo? Have you ever used hack local up cluster?
Never. I've seen you use them, but I've never used it. I know that Teams and other folks, they like that one, right?
Oh my God, it's great. Yeah. So it's just a shell script, and it's inside of Kube, and you just can go here, and it'll just literally build whatever's in source, and it'll deploy it locally, right? So I can start my cluster here locally, And like I've already got a kind cluster, so let's just so I could see kubectl get pods-a. I could see this is my kind cluster that's running, right? But I'm on the same machine, and I'm like, okay, what if I wanted to run just a pure Kubernetes cluster, right? So I'm running these services locally. So it's literally starting every single thing like in a bash script, right? So it's just waiting for this. It's just a function, and it started it as a Go process, right? As a Go command. And anybody can just run this. You just clone it down and you sudo hack local-up-cluster, and it'll compile all of Kubernetes from source. And then after it compiles it all from source, it'll run everything one at a time. So you have to do one other thing when you do this. You have to do this. Oh God, I killed it. I shouldn't have done that. You have to do this one thing, which is you install etcd. This is another hack script that comes with Kube, though, is this hack etcd, right? So you hack install etcd, and then it puts etcd on your path, right? So I can just start up etcd so you can see it running here. So it puts etcd on my path, and then I can just do hack local-up-cluster. So I'm going to run it again, wait for it to come up, and then we'll see if it's working. And now we'll go back and see. Let's see how our Red Hat clusters do. Yeah. Okay, so now this is running. So we could see the logs here. It's going off, and we've got the whole OpenShift thing going on. It's running OpenShift installer v48. We can see the logs. It's waiting for the API server to come up. We've got a DNS name, Ricardo. Okay, now the yeah, Carlos. See, I told you it was going to heat up eventually. So okay, yeah, local-up cluster. It's cool. Try it out. So here, okay. So here we go. It's up, right? So there's nothing. So it's almost up. It's not there yet. It's polling. It's waiting for it to come up. Now it's up. Okay. So now I could do. I have to export this. I have to export that, right? So now I can do kubectl get pods-a. Or do I have to do this? Yeah, I don't know why it has both these commands. So if somebody wants to, like, you literally can just do kubectl. You don't even need to do cluster kubectl.sh. But anyways, so kubectl.sh is just like it just runs kubectl. It's just an alias to it. So, and I think it's using the compiled version of kubectl that we just compiled right now. So that's kind of nice. So we could see that's all. It's not running anything other than kubedns. So you got bored with VMware, got back to watching with ESX. Yeah. So okay, well let me show you. So there's this one. This was the other one I was going to do. So we have Azure too. So I was going to show you this, but we ran out of time on the Tanzu stuff. So for Tanzu, I also have an Azure cluster here, and we could do all the same stuff. We could do Tanzu cluster, create -- help, and we could actually. This is a VM that's in Azure, but it's too late for that. We don't need to. But yeah, we could use it. We could use the Tanzu stuff. I guess the point of that all, Carlos, was not so much about it. The point wasn't about ESXi. The point is more about the cluster API side of things. I think that's the interesting thing, because you can use cluster API with any cloud, VMware, ESXi. I'm sorry, VMware, EKS. I'm sorry, VMware, Amazon, Azure, any of those. Google, right? There's a cluster API provider for Google, API provider, GCE, right? So, like that, and that fundamental thing of being able to make clusters and machine deployments and all that, that is something that's like fundamental to what we do inside of Tanzu, but it's not specific to VMware in any way. So anyways, we've got local-up cluster running, and let's see, if I do kubectl, if I do cluster kubectl.sh version. So we could see here, right, that it literally just built it from this dirty commit that we have in tree, right? And then the other nice thing is here, if I want to play with something, like I want to change some code, right? So I can go into vim package kubelet, kubelet.go, How's your OpenShift cluster coming, by the way, Ricardo? Any luck?
It's almost there.
Yeah.
It's
Right.
it has downloaded like half of the internet here, like 15 gigabytes. I am almost out of bandwidth, but it's almost done. At least it's bootstrapping here.
So I can, for example, if I wanted to just do something stupid, right, I could go into my kubelet and I could write this function, right? And let me say, make sure FMT is in here somewhere. Yeah, it's in there. So I could do this, and then I could rerun hack local up cluster, and then I could retry to compile it, and we'll just be able to see that, like, once it compiles, all that stuff will be running in there, like the code I just made. Carlos warned us that it was going to be, can we download tons? So, Martin, you know, if you want to play around with it, reach out to me after the show, and we could talk more about it. I don't know how the trials and stuff work for it, but yeah, we definitely can try to figure out some way you can set it up. So, and there's always stuff going on, I'm sure, with, you know, with marketing and whatnot. I don't live on that side of the house. But, you know, one cool thing about Tanzu is it's all cluster API, Martin. So if you really wanted to learn about Tanzu, one great way to learn about it is just to try out cluster API. So you can, if you go to cluster API, you can get started with it really easy, because there's a cluster API provider for Docker that literally makes Docker machines as VMs. It's called kpd, right? But I think they're going to move this. So this is actually now integrated into cluster API. But literally, if you wanted, you could just and I think there's a TGI. There might be another TGIK about this. If not, we could do one. But yeah, so you can try out cluster API just locally. I think using what's in this repo here, cluster API test infrastructure Docker. But again, yeah, reach out in the cluster API channel on Slack to talk more about it. So, so it didn't work, right? So it didn't start, and of course it didn't start because the kubelet never started, because I put an infinite loop in there. So if I go and I look at the ls var log, where did I put the kubelet logs? I think it's in temp. Cat temp. Kubelet.log. Yeah, see this? See, I put an infinite loop in the kubelet to print Ricardo, and then so it failed. So my thing never started, right? So so you can see it's like that easy, right? I can just like modify the source code and run hack local up cluster, and then I could just see my changes right there and there, and I can just, that's how you build and develop and add features to Kube, right? Is hack local up cluster. So that's a really nice tool. Okay, so so we got hack local up cluster. I got a list here of everything I wanted. So GCE, OpenShift, Minishift, whatever. Firecracker one, Choco. I think we should do that. I don't have an EC2 account, so I can't try it. But maybe for another episode. Again, feel free to reach out sometime. Yeah, Tanzu is really like it's a productized version of Cluster API. Exactly. So it's a multi-cloud centric, sort of upstream centric Kubernetes distribution from VMware that you pay for, right? Just the same way that OpenShift OpenShift has an OpenShift analog, OpenShift origin, and then there's what you pay for. So what's next? Let's see if my cloud thing came up, and then if not, let's see if well, Ricardo, did you get yours up yet? Mine failed because I exceeded quota, so I couldn't get it up and running.
Oh, mine is online.
Yours is on. Okay,
Finally,
so all right, so let's share your screen and let's take a look at it.
Okay, let me open Google Chrome here. And yeah, share my screen. And I want to share.
Yes, Carlos. Yeah.
How can I share my terminal? Only my terminal. Where is my terminal, Jay? Okay, I'm gonna. Okay.
How would I know?
Share new tab. Okay, I'm sharing my new tab, right? You can see my new tab.
Yeah, I see it.
So okay, cool. So to install CodeReady, I am running on my machine here, and I did something like CRC setup, then CRC start, and it started that for me, right? So now I can access the I can access the API using using their URL, but I am not sure which IP address is this one. So let me see, because it seems that it created something locally in my machine, and I am not sure what's the name that it created locally. So I will have to do some etc host something here. All right. Let me see if I can like export my screen here. Firefox -no remote. No. Okay. I'm just thinking because I can't. All right. I know how to do that, Jay. Hold on.
No problem.
I'm just gonna create like a tunnel. 30. Right. So let's see if now this works. I hope so.
Oh, that looks better. This is unsafe. Okay.
Application is not available. Maybe not have been started or ended. Yeah. So I would have to look, because I did like a tunnel here.
Why don't you look and I can show him GKE while you fix it?
Sorry?
I can show him GKE while you fix it. How about that?
Okay. Sounds good.
Yeah. Okay. So let's jump back to mine, and then Ricardo's going to work more on the OpenShift stuff. And then meanwhile, I'm going to jump over here and see if I can get, I set up a GKE cluster on here, and I want to see what I can do I want to see how that one is, whether it's happy or not. So if I go over to my Kubernetes, here we go. Yeah. Here we go. So here's my first cluster. So I can do the same thing I did with Azure here. Let's connect to it. Let's run that in Cloud Shell. So again, I can just do my little native Cloud Shell thing again. And let's see what we've got for, like when I made this. All right, so we get our Cloud Shell for free. And let's see, kubectl get pods -a. So I wonder if we can do the same debug trick. So if we do kubectl nodes get nodes, can I do the same debug pod thing that I did earlier? Debug. Okay. So if I do one of these, I'm curious whether this works again. Sorry about that, folks. See. So I'm going to try to run another debug container in here. I'll add this to the show notes. Yeah. Okay, cool. So I was able to do that. So now we can snoop around and see what's. If you wind up getting it working, just let me know. Ricardo will switch over. So now I'm inside of my Google cluster, and now we can look in here and we can see what's running. Yeah, we'd love that, Carlos. Definitely. Yeah, we did. We'd love that for sure. In fact, why don't you are you on Kubernetes Slack, Carlos? I'm on every Slack. Cool. We'd love to have you jump on here. If you're on right now, we'd love to just we don't have too much time left, but I'll DM you. Let me DM you so you can
So as Carlo told, like it's a bit painful to make work with etc hosts or local DNS because it asks like it keeps redirecting you to other places. I guess we are out of time, but one solution that I would have is actually to open like a SOX proxy in my remote machine and just pass every single request through that one. So it would like direct me to places that I need. But right now, I don't think we are gonna have time for that.
No, yeah, we can do it for next time. So I'm in here and I wanted to go over the GKE like default options if I wanted to. And let's see, like if I wanted to make another GKE cluster, there's two different modes. There's autopilot and standard mode. If I want to, I don't know what autopilot is. I don't want to try it. I want to see what CNI options we have. So I can make, so I guess like, how do I pick my CNI? So if I go here, it's kind of like, I'm wondering like why, this is, so, okay. On this tab over here, they have all the options for networking. And so like, I'm like, let's see. So you can enable node local DNS. This just for faster DNS resolution. You can enable network policy. So how do I pick my CNI provider? I wonder, because it doesn't give me an option for that. Did you know can you pick your CNI provider inside of GKE, Ricardo? I don't know.
As far as I remember, you need to use like that enable that data plane v2. Go down. Yeah, so that one you are gonna enable Cillium, right?
Data plane
So
v2 brings
I guess
greater.
this is
Yeah. Okay. So I can't pick different CNIs. They just basically say Cillium or Google CNI, and that's it. Okay. And so the other options are confidential GKE, workload identity. Okay. So these are the options on this one. And then so we didn't get OpenShift. We do have a Google we do have a cloud. We have a GKE one running. Obviously GKE is like kind of the easiest of all of them. And then at some point Carlos will join us and maybe he will show us how to run OpenShift, and we can do another one of these episodes if folks liked it, where we look at the existing tech. So if I do in here, if I want to see what the pods are that run by default on here, I've got a connectivity agent, I've got PDCSI, I've got Stack Driver, which is Google's like log thing. What's connectivity? I don't know what that is. Is that an upstream thing? Okay, so this is an upstream thing. TCP level proxying for control plane to cluster communication. So that is this a thing where if your API server isn't like L3 connected to your nodes, it allows them to talk? Maybe that's what this is. I don't know. Service account token volume projection feature get is enabled. You can enable service account token volume for providing following flags to okay. What's this API server network proxy thing?
I have no idea.
Well, evidently it's a thing because there's a KEP about it. So we'll run a connectivity server inside the master network. It could work on HTTP. Oh, here's a diagram. Can be extended without recompiling K8s. What's the problem statement? Usually in every KEP, there's usually a problem statement at the beginning. Traffic egress or network proxy system. The K8s can be configured to send traffic or not to one or more of the proxies. Users can drop in custom proxies if the default. Motivation. Kubernetes has outgrown SSH tunnels. They complicate K8s Kubernetes API server code, I guess. Is that what that is? And only one cloud provider implemented them. After a year of deprecation time, they'll be removed. So, so there's some kind of DIMS. Okay, so this used to be a thing where you could set up when you ran your API server. I guess you could give Kubernetes an SSH key, and then you could dial into nodes and do stuff maybe. So this is, in retrospect, having an explicit level of indirection that separates the user initiated is a useful concept. So I guess the idea is get rid of this SSH tunnel node dialing thing from the API server, enable admins to fit. Okay, and then we'll run a connectivity survey inside the master network. It would work on an HTTP connect for the alpha server. For scalability, we'll be looking at the number of users. So do they have an example of how they want you to use it? Comes from incoming requests. Here we cover the outgoing requests. This is our understanding of those. Okay. Yeah, so I guess, here's the user stories. Customers can run a cluster which combines master and cluster networks. They configure all their connectivity configuration to direct this bypasses the proxy and optimizes from. Customer may want to isolate their API server from the cluster network. Okay, so yeah, that's the idea. It's the idea that you have an API server somewhere and you've got a cluster network somewhere else. And now this makes perfect sense because if you have this connectivity thing and you're running GKE, right? Like if I'm creating a cluster here in GKE, then my API server, the GKE API server may not, like I don't have access to it. Like you can't see it, right? Compare that with like the Tanzu cluster we ran earlier, right? Where we could see every pod running, right? We could see the kube proxy, we could see the API server. In this case, when I say look at pods, I don't see any system pods, right? Everything, well, I see the kube proxy, but I don't see anything else, right? And so the API server, the whole control plane in GKE is running in another network, right? And so because of that, I think that's why they have this connectivity agent, is it allows that other network to work with the nodes in this network. I think that's the idea, because there's an agent, 1, 2, 3 agents. I have like a 3-node cluster and I have 3 agents. So I suppose that if I looked at the logs of these, like they would be saying like kubectl logs -n kube system. These probably would be saying like, oh, someone from the API server tried to talk to me, right? Yeah. So something's going on. Someone wants to do something here, right? So I suppose that's what this thing does. This agent just sits here and I don't know, receives things coming from the outside world. That's my best guess at what that would do. And then what other options do we have here? Istio. I didn't know people still used Istio. Oh, it's beta. That's why. Okay.
Actually, a lot of them use it.
Okay. I thought people are starting to use Linkerd nowadays. Well, we should have tried Istio, but maybe for another time. Enable GKE usage metering. What's TPU, Ricardo? Accelerate machine learning? We don't care about that. Not today, at least.
Why don't?
Okay.
Why? Go ahead, Jay.
Go on. No, go.
No, I was just going to say to Carlos that I could make it run localhost, so I can write a blog post and sell to them, so they can show to their customers. I'm just kidding.
Yeah.
But I did that with like a SOX proxy, and it's working fine here.
Oh, okay. Well, maybe next time we can do that. So like if folks like this idea of looking at different real world K8s distributions and how they work and want to do it like one level deeper, we could totally do that next time. Carlos, hi, thanks for showing up. If you want, the show's almost over, but if you want to give us a quick 5-minute overview of what you're doing over there with the IBM stuff, we're happy to take a look.
Sure. Can you hear me?
Yeah.
I don't know which mic I'm using.
Yeah, we can hear you.
Can you remove that banner from the bottom? Let me see if I can share my screen.
Yeah.
Sharing my screen. Thank you for having me. I was having a ton of fun just trolling.
That's fine. While you get the screen ready, just in case.
Did I share my screen now?
Yeah. Go ahead, share your screen. And as you do that, I'm going to kick one thing off and show people. There's one more distribution I wanted to show people. So we showed you Hack Local Up. We showed you the commercial ones. There's one other one which I wanted to show you, and we'll dive into it deeper another time. But we have these Windows.
Just increase your phone, Jay, please.
Yeah, cool. We have these, and these allow you to spin up a mixed OS cluster. So I can clone this down. This is here. This is here, sig-windows-dev-tools. Here it is. Here it is. So I go here, and I can clone this down, and I can make a local 2-node cluster again from source. I just have to do make all. And so this will spin up two nodes, a Linux node and a Windows node, and it'll spin them up both from source. We'll do a whole overview of how this works. We're integrating image builder into this, which is a way to build immutable OS images. So we'll do a whole episode on this at some point. Amin will probably do that episode. But just wanted to show people there's one other tool that is another official Kubernetes way to build development clusters from source. So the Hack Local-up-cluster kind, and then this one if you're interested in doing the mixed OS thing. So go ahead, Carlos. Let me share, and go ahead and talk us through what you've got going on over there at Red Hat. And then after that, I think we'll get going because it's late and everybody wants to go hang out and party because it's Friday.
Yeah. Hi, I'm Carlos Santana. I work for IBM, but I do a lot of stuff with both Red Hat and upstream Kubernetes. So this is IBM Cloud. We have a cloud. So if you have an account, we offer a free Kubernetes cluster. And also we have like sandboxes with OpenShift. So OpenShift or just vanilla Kubernetes, we call it the community edition, is the one that you can get in IBM Cloud. I'm logged in for free. You can get one Kubernetes cluster. I think it's one node that you can play it around.
Carlos, if you could just dig into the tech since it's TGIK, let's try to get in there and not do too much business stuff. Yeah.
So just wanted to show that we have two options. So you can get a Kubernetes cluster here or an OpenShift cluster here. So if you do Kubernetes cluster, you get an option to create a cluster. So you can do it from there, multiple places. You can select the OpenShift one, or you can select the version. So 119, 121. A few minutes ago, I started one. Let me see where it is. So if you select like what are the options that you want, and then at the end you select the version that you want. So this is a different account. So I started one with I think it's still ongoing. So when you start Kubernetes cluster, it takes a few minutes, like you saw, right? But once this is done, then you get something like this, where you can just have the red cluster, which is OpenShift or Kubernetes, and then you can just launch the OpenShift console.
So what does this run? Does this run Oven Kubernetes, or does it run Calico, or what's the
Calico? We use Calico on both.
Okay.
Calico on OpenShift and also on IKS. We call it IKS.
Okay.
As any managed cluster, you are in charge of your Kubernetes cluster, not the worker nodes, right? So what is it used for storage? We use
like
for
could you
OpenShift,
show
we can use
pods that are running and stuff?
Yeah. So here's a little shell that we have. If you click on the shell here, you get a little shell, and then here you can log into the shell. So I can do kubectl get reconnect. You can do kubectl get pods, and you can see the pods that are running. Get pods, and I have a cluster here. And it's using Calico, so you get network policies, and you get a load balancer. So if I do kubectl get pods,
Can you zoom in on your font a little, Carlos?
yeah, let me see here.
Cool. So let's see what you run. So you're running Multus. That's interesting.
Yep.
Okay. So what do you use Multus for?
Multus is an abstraction for the CNI, right? So it's a way to select which one you want.
But you're only using one CNI, right?
Yeah, because it's a managed. I don't know why this thing is not responding. Let's see if I can have here kubectl get pods in my local terminal since I'm connected to the same cluster. I'm not authorized. Let me log in for a second here.
Thanks, Friedrich, for showing up.
Yeah, let me log in into my local one because
cool.
I think it's because I'm sharing.
You know what? Do that, and then I'm going to jump and show them something, and I'll come back to you in a minute, okay? Because I want to show them the progress on my other one. So I'm back on my cluster over here that we're spinning up from Kubernetes SIG's the Windows DevTools, and you could see here the control plane is now sort of coming up. It's not up yet, let's see here. So we've been running for about 10 or 15 minutes, but like this is the first step. So in this case, the nice thing about this one is you get to see it just uses pure VMs, and so you could see everything that happens when you make a multi-node cluster. So it's doing a join now. Similar to the hack local-up cluster, it's really low level and gritty, but at the same time in this one, you actually have two different machines, and one of the machines is a Windows one. But so in this one, and you can SSH into both of the nodes. So I can CD over here, source, and I can do vagrant status. And then I'm going to come back to Carlos. And I can vagrant SSH into control plane. And then I could kubectl get node. So I can use this as my sort of bastion that I control everything from. And in a minute, the second node will be up. The Windows node takes quite a bit longer, just because Windows on Kubernetes takes a while to install. But that'll come up in a second. It'll bootstrap everything from Kubernetes 1.22. So it's really the only way to actually develop and run rapidly against bleeding edge kube for Windows. So, okay, back to you, Carlos. Let's see how your situation is going.
Where's the window? Am I sharing now?
Yeah, you're sharing.
Okay, I think you switch. Yeah, so you were asking about the CNI. We use Calico. So if you do kubectl, right, get CRDs, you will see the typical network policies that you can use. Both the OpenShift flavor and just the vanilla upstream Kubernetes. So you don't have to use OpenShift in IBM Cloud. You can use OpenShift or you can use Calico. OpenShift for upstream. This one happens to be an OpenShift cluster, and use Calico. You were asking about the different storage. We can do the storage classes. You can select, like we give you storage classes based on the speed that you want, like the IOPS. So we have like gold versus bronze versus silver, and then some of them will have read write many, and some of them will not have read write many. Or you can just use like, you can hack around. Like I set up an NFS, so I'm using also NFS here.
Yeah.
And basically you can go to the console or the CLI and request in IBM Cloud a cluster, and then it takes a few minutes, depending how big is the cluster. So this is a 5 worker node, and we give you a nice utility to either log in through the